In this video, I'm going to show you the solution to a sample test at mathematics taken by students in Romania at the end of the 8th grade. Task 1. Calculate 15 divided by 5 minus 4. First, we calculate the second degree operations, division, and then the first degree operation, here subtraction. So 15 divided by 5 is 3. 3 minus 4 is minus 1. Calculate the arithmetic mean of the numbers 6 minus 2 square root of 2 and 2 square root of 2 minus 4. The arithmetic mean of two numbers is the sum of the numbers divided by 2. So we add these two numbers together and we obtain 6 minus 2 square root of 2 plus 2 square root of 2 minus 4 all divided by 2, which is 6 minus 4 divided by 2, which is 2 divided by 2, which is equal to 1. Consider the set A of the set of number x with the property that x belongs to the real numbers and module of x is less or equal than 5. Write the A set as an interval. Module of x is less or equal than 5, which is equivalent to minus 5 is less or equal than x, which is less or equal than 5. So x belongs to the minus 5 interval closed at both ends. So A is the minus 5 interval closed at both ends. A square has the diagonal of 5 square root of 2 centimeters. Calculate the perimeter of the square. Let S be the side of the square, D the diagonal of the square, and P the perimeter of the square. We know that the diagonal of a square is side multiplied by the square root of 2. So the side of the square is the diagonal divided by the square root of 2, which is here 5 square root of 2 divided by square root of 2, which is 5. The perimeter is 4s, which is 4 times 5, which is 20 centimeters. A cube ABCD A prime B prime C prime D prime is shown below. The edge of the cube is 6 centimeters. Calculate the lateral surface area of this cube. The lateral surface area of the cube is the perimeter of the base ABCD times its height. So 4 times 6 times 6, which is equal to 144 square centimeters. The marks taken by students in a class at a mathematics test is shown in the table below. Calculate the arithmetic mean of the grades obtained by the students in this class. We multiply each grade by the number of students who have taken that grade and then make their sum, which we divide by the number of students in the class, and we obtain an answer of 7.68. Task 2. Draw on the exam paper sheet a regular triangular prism ABC, A prime, B prime, C prime. We draw and annotate the prism. Calculate the geometric mean of the numbers A equal to 2 divided by square root of 3 plus 1 and B equal to square root of 6 times square root of 2 plus 2. In order to bring number a to a simpler form, we rationalize the denominator of the fraction by amplifying the fraction with the conjugate of the denominator, in this case square root of 3 minus 1. By making the calculations, we obtain that a is square root of 3 minus 1. B is square root of 6 times square root of 2 plus 2, which is equal to square root of 12 plus 2, which is equal to 2 square root of 3 plus 2, which is equal to 2 times square root of 3 plus 1. The geometric mean is the square root of the product of A times B, and which is equal to 2. Mother is 30 years old and daughter is 4 years old. After how many years the age of the mother will be 3 times higher than the age of the daughter? Let A be the mother's age, so A is equal to 30. Let B be the daughter's age, so B is equal to 4. Let X be the number of years elapsed until condition is met. We have A plus X is equal to 3 times B plus X. So A plus X is equal to 3B plus 3X. A minus 3B is equal to 3X minus X. So X is equal to A minus 3B divided by 2. By making the calculations, we obtain that X is equal to 9. Consider the function f defined on R with values in R. F of x is ax minus a plus 2, where a is a real number. Calculate f of 1. B. Determine a belonging to R so that f of 2 is 4. A. F of 1 is a minus a plus 2, so f of 1 is equal to 2. B. F of 2 is 2a minus a plus 2, which is a plus 2. F of 2 is equal to 4, so a plus 2 is equal to 4 and a is equal to 2. Consider the expression x squared plus 4x plus 3 divided by x squared plus 2x minus 3 minus x squared plus 2x plus 1 divided by x squared plus 3x plus 2 multiplied by x plus 2 divided by x plus 1, where x belongs to R without minus 1, 1, minus 2, and minus 3. Prove that the expression is equal to 3 divided by x minus 1, where x belongs to R without minus 1, 1, minus 2, and minus 3. We can write the numerator of the first fraction as x plus 2 squared minus 1, and the denominator of the first fraction as x plus 1 squared minus 4. And we can also write the numerator of the second fraction as x plus 1 squared and the denominator as x plus 1 squared plus x plus 1. By making the calculations, we can prove that the expression is equal to 3 divided by x minus 1. Task 3. A carton of juice is in the shape of a parallelepiped with the dimensions of the base 6 centimeters, 7 centimeters, and the height of 24 centimeters. A. If the lid is in the shape of a circle with a diameter of 1.5 centimeters, calculate the surface of the cardboard used. B. Determine whether this box can hold 1 liter of juice. C. If during the manufacturing of the box 10% of the cardboard used is lost, determine whether 778 square centimeters of cardboard are enough. At point A, we assign the length 7 centimeters, the width 6 centimeters, and the height 24 centimeters. The total area of the parallelepiped is the perimeter of the base times its height plus 2 surface of its base. By substituting and making the calculations, we obtain a total area of 708 square centimeters. Considering that the lid is manufactured from a different material, the surface of the cardboard used is total area minus area of the lid. We know that the diameter of the lid is 1.5 centimeters, which is equal to 2 times the radius of the lid. So the radius of the circular lid is 1.5 divided by 2, which is 0.75 centimeters. The surface area of the lid is pi times the square of the radius of the lid, which is approximately 1.766 square centimeters. So the surface of the cardboard used is 708 minus 1.766, which is 706.234 square centimeters. B. The volume of the box is length times width times height, which is 1008 cubic centimeters, which is 1.008 cubic decimeters, which is greater than 1 cubic decimeter. We know that 1 cubic decimeter is equivalent to 1 liter, so this box can hold 1 liter of juice. In point C, we have the surface of cardboard 778 square centimeters. The surface of cardboard used is the surface of cardboard minus 10% times the surface of cardboard, which is 778 minus the 10 divided by 100 times 778, which is equal to 700.2 square centimeters. From point A, we can see that the surface of cardboard used is 706.234 cubic square centimeters. So 778 square centimeters of cardboard is insufficient considering the 10% loss during the manufacturing process. In the figure below, it is represented a square-shaped garden with a side of 15 meters. The diagonals represent access alleys. In the 4 triangles formed, the different flowers are sown, and at the junction of the alleys there is a lawn. The length of the AX segment is 0.5 meters. A. Calculate the surface area of the garden. B. Calculate the surface area sown with flowers. And C. Calculate the surface area of the lawn. The surface area of the garden is the side squared. We know that the side is 15 meters, so the surface area of the garden is 15 meters squared, which is 225 square meters. BZ, we can see from the figure that BZ is equal to AX, which is 0.5 meters. XZ is AB minus AX plus BZ, which is 15 minus 0.5 plus 0.5, which is 15 minus 1, which is 14 meters. YX squared is AY squared plus AX squared. YX squared is 0.5 squared plus 0.5 squared, which is 0.25 plus 0.25. So we have YX squared is 0.5. YX is the square root of 0.5, which is approximately 0.707 meters. From the triangle FBX, we have with Pythagoras theorem that fx squared is fb squared plus bx squared. So fx squared is 14.5 squared plus 14.5 squared. Fx squared is 210.25 plus 210.25, which is 420.5. Fx is the square root of 420.5, which is approximately equal to 20.506. Let M belong to the segment Fx and P belong to the segment Fx. The segments FP and MX are equal and are equal to Fx minus MP divided by 2, which are equal to 9.9 meters. The triangle MXZ is isosceles, so MX is equal to MZ, which is equal to 9.9 meters. Let the segment MG be the height of the isosceles triangle MXZ. So XG equals GZ equals 7. From the triangle MXG, we have with Pythagoras theorem that mg squared is equal to mx squared minus gx squared, which is equal to 49. So mg is the square root of 49, which is 7. The surface of the triangle MXZ is xz times mg divided by 2, which is 49 square meters. The surface area sown with flowers is 4 times the surface area of MXZ, which is 4 times 49, which is 196 square meters. The surface of the lawn is 0.707 squared, which is 0.5 square meters. This was the solution for this test sample. Thank you for your attention. Goodbye. In this